In this video, we're going to go over the 9.1 check and reflect on page 310. The first question is, list 3 reasons that early cultures, including First Nations and Métis people, had for observing and keeping track of celestial phenomena. So by keeping track of the phenomena, it could indicate to them when the growing seasons would start, when they'd have to prepare for it. It also allowed them to tell which hunting seasons would be occurring soon, particular for the Plains First Nations, the migration of the buffalo. And in the evening, it could also be used for navigation. Question 2, how have observations of the natural world helped in the development of calendars? So through observing the sun, ancient peoples recognized solstices and equinoxes. This helped divide the year into 4 different parts. The changing position and path of the sun and the stars were observed, and structures were built that aligned with the events. These structures were the first calendars. Question number 3. If an alien were to come to Earth, how would we explain constellations to the newcomer? Would the constellations appear the same as on the alien's home planet? Explain. So this would be kind of a science fiction question similar to what I referred to in our introduction video. But hypothetically speaking, let's say there was an alien that came from another planet. So that planet would be situated in a different spot in the universe. So if our planet's here, their planet's here, if we had a star up above in between the two, it would look totally different from our two perspectives. So the patterns would not be the same as they would be on Earth. And even when we are on Earth, there are differences as well. So, for example, we're located in Saskatchewan. The constellations that we see are much different from the Southern Hemisphere. For example, let's use the North Star. In the Southern Hemisphere, well, they absolutely can't see it because it's directly above the northern point of Earth. But in the Northern Hemisphere, we don't see features such as the Southern Cross that is used for navigation in the Southern Hemisphere. So 2 different patterns of stars. Question number 4. Use your own words to define the differences between solstices and equinoxes in terms of what time of year they occur. So the solstices for us in the Northern Hemisphere, June 21st is the summer solstice, which is the longest day of the year for us, and December 21st is the winter solstice, which would be the shortest day of the year, so the day in which we get the least amount of sunlight. Now, the equinoxes occur on March 21st in the Northern Hemisphere. That would be the spring equinox, and it's usually around the 21st. There's a little bit of variation, and around September 21st for the fall equinox. Question number 5. Why would the observation of solstices and equinoxes be so important to various cultures? These dates are very important for every culture in the world because those mark different periods of time, which could indicate a time for gathering, hunting, fishing, planting. So essentially, it was for the foods we needed for survival. So those dates are extremely important. Question number 6. How could ancient cultures predict solstices and equinoxes? So these predictions were based on a multitude of years of observation. And from those observations, they were able to develop structures, which were essentially calendars, to help them predict or observe when those solstices and equinoxes would occur. Question number 7. How have observations of the sky enabled humans to explore and travel? Now, during the day, the sun could be used for navigation, and at night, Polaris, or as we commonly know it as the North Star, could be used to help guide people. Now, these observations of the sun and Polaris became extremely important once sailors started going farther out into the oceans. Without any visible landmarks to be seen, they had to rely on their astronomical observations. Question number 8. In your own words, explain altitude and azimuth and how they are used in determining objects in the night sky. So there might be a little bit of variation in between your questions, but it should include the fact that altitude is measured from the horizon up toward the point directly overhead, or the zenith. The position of the altitude would be somewhere between those points. This gives the vertical coordinate. A horizontal coordinate, or azimuth, is determined by locating it from a point clockwise from due north. This value ranges from 0 to 360 degrees. Question 9. How would an astronomer locate a specific star if she or he were only given the right ascension and declination? Okay, so right ascension is similar to longitude, while declination is similar to latitude. The two coordinates are part of a system that is on a celestial sphere. The location of the object would be similar to finding a location on the globe. Question number 10. Why are altitude and azimuth expressed in degrees while right ascension is expressed in hours, minutes, and seconds? Altitude and azimuth only refer to the location at a specific time, because as the Earth turns, the station of the stars in the sky will be in a different spot from our perspective. Using right ascension takes into account the sky rotating every 24 hours, and so that way the location is more specific. Okay, question number 11. What early forms of technology were used, A, for predicting solstices and equinoxes? Now, many different cultures developed various structures which were in reality a calendar for determining when the equinoxes and solstices occurred. Some of the more famous ones that we've seen in the world would be like the Medicine Wheel by Moose Mountain, Saskatchewan, Stonehenge in Great Britain, or Machu Picchu in South America. The Aztecs and the Mayans both developed calendars for predicting those dates as well. For B, for navigation, one of the earliest forms or methods they used for navigation would have been using one's old body and the position of the sun or Polaris to determine your location. Later, more accurate equipment was developed, such as the Camal, the sextant, or the quadrant. All these technologies use the sun and Polaris as a guide for navigation.